Today, Brian is going to be pretty intense. Don't quit on me, and you'll be fine. I've done this before. What we're going to be doing is we're going to be deriving the 4 kinematics equations. Which are the 4 kinematics equations? Can you all look at your green sheet? And it's the 3rd row down that starts out with VF equals VI plus AT. That's the first one. Next to it, there's D equals, and it's got some brackets. That's the next one. The one next to that is D equals VIT plus a half AT. That was the next one. And the last one is VF squared equals VI squared plus 2A. I put them all in a row. Those are the 4 kinematics equations. Brian, you want your green sheet open to the front page, please? And don't be working on other stuff. You want to be focusing on today's lesson because this is a very, 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 very important one, please. I'm going to spend the next 20 minutes or so deriving the equations. I will not make you derive them on your own on a test or a quiz. But I'm enough of a nerd that whenever I introduce a new concept to you, I don't like going, hey, just trust me. I'll say, this is where it comes from based on what we've already learned. So there will come a point when I say to you, here's what's fair game for the test. All right? We started out yesterday, we defined what acceleration was. We said that acceleration was the velocity change per second, and velocity change can be found by multiplying A times delta t. Say what? Velocity change can be found by multiplying A times t, acceleration times time. And Brian, what's change in anything? So instead of writing delta V underneath that, I can write final VF minus initial VI equals AT. And then, Brian, I'd like to get the VF by itself. I'd like to move the VI over. What's the VI doing to the VF? Adding, subtracting, multiplying, or dividing? So how could I move it to the other side? What's the opposite of subtraction? And if I rearrange that, then this gives us VF equals VI plus AT, which I think is the first equation in that row of 4, 3rd row down. Yes? This pops out of our definition of acceleration. Oh, time is always a change in, which is why I wrote t equals delta t, and so we get lazy. We just put the t because we're just lazy. Okay. Now what? Well, to find the displacement an object travels, we can't use this. Don't write that down. Don't write that down. That only works for a constant speed, not a changing speed. What we can use is this, d equals v average times t. And in fact, that's what I'm going to write in this box right here, but write it small, d equals v average times t, because I'm going to take that one step further, and I'll write my final equation larger. I have to talk about what we mean by average. Let's suppose Mara has $10 and Gerard has $20. Between them, what do they average? How can you get a 15 from a 10 and a 20? What did you do? How? You, without realizing it, you added them up and divided by 2. That's average money. It's the same for average velocity. Over here, we're going to write this. V average equals VI plus VF divided by 2. Oliver, what's V average? Read this to me. And what you're going to find is often I'll ask someone a question, and when they have the right answer, I'll have them repeat it. That usually means it's an important concept, not that I'm making fun of you. So can you read that again? What does V average equal? So when I see a V average, what can I replace it with? Same thing. I'm going to do that right here. Instead of V average, what am I going to write? And that's going to give us our second equation. Now I'll have to put the VI
plus VF in brackets, because there's a T on the outside, divided by 2.
I think that's the second equation on your formula sheet in that row of 4, yes?
Oh, and now we can bring in the vector symbols. I get sloppy when I'm doing the rearranging, and I usually bring in the vector symbols at the very, very end.
So this equation works for both displacement, velocity, velocity and time, or distance, speed, speed and time. It'll work for both. Again, though, Jesse, this assumes uniform or unchanging acceleration. You can step on the gas, you can hit the brakes, but once you commit, you can't press harder or ease up. If you have changing acceleration, there's calculus-based versions of these. So, Oliver, how can I find average speed? What was the equation? Can you read it to me again? Okay. Let's put that in our back pocket temporarily. And we're going to turn the page. So we said distance is average speed times time. So that was VI plus VF times T over 2. But Gibson, what does VF equal? Can you read me the very first equation from that row on your formula sheet, the one that says VF equals? What can I replace the VF with? Say it again. So whenever I see a VF, what can I write instead? Say it again. I'm going to replace this VF right here with, you know what? And when I do that, I get this. D equals VI and then plus VI plus AT times T over 2. I just replaced that with that. Substitution. But now I'm going to tidy this up. What's 1 VI plus 1 VI? Okay. By the way, here's your spoiler alert. I'm now trying to head to the third equation on that list of 4. So see if you can spot how we're going to get there. I can write this as, Gerard, you're correct, in brackets 2 VI plus AT times T over 2. Now, Gerard, I'm going to get rid of brackets. I'm going to go times the T onto that. I'm going to times the T onto that. Usually in math, it's in the front of the bracket, but it works the same way. Multiply it on everything in the bracket. When I do that, I'll get D equals 2 VIT plus AT. Wait. What's a better way to write T times T? I'm going to write AT squared. And that's all over 2. Again, let me emphasize, I'm not going to ask you to rederive this, but I'm just showing you where these 4 equations come from. Gibson, is this first term over 2? Say yes. Is this second term over 2? Say yes. Then you're allowed to split them up. You can write this as D equals... Hang on, draw a little arrow. D equals 2 VIT over 2 plus AT squared over 2. Now, why would I split them up, Gibson? See that first fraction? Is there a T on the top? Is there a T on the bottom? Is there a T on the top? Is there a T on the bottom? Say yes. Those T's cancel. And I get this. D equals VIT plus, and then typically instead of writing AT squared over 2, for some reason we just write a half AT squared, because dividing by 2 and timesing by half is the same thing. I think, double check, is that the third equation on that list of 4? And the reason I keep referring to these is you want to make sure you know where these are so that your eyes glance in the right location on your formula sheet. In the same way as when you have a periodic table, none of you have memorized the periodic table, but I'm willing to bet when you were in your science classes doing chemistry, if you thought of an element, your eyes kind of glanced roughly in the right area because subconsciously your brain had kind of started to filter stuff. I want the same circuit to develop. So I'm going to keep saying, look at your group green sheet, look at your green sheet, look at your green sheet. There's one more. This one I'm not going to derive. It's going to pop up later on in the course. It's going to fall into our laps. If you want me to show you how to derive it, hit me up during a flex block. It's the fourth one. Moses, can you read me the fourth one from that line of 4 there? It starts with VF squared.
Yeah. Equals VI squared plus 2AB.
And both of these work whether they are vectors or scalars.
These are the 4 kinematics equations. If you take physics 12 with me, you won't learn any new ones. In fact, you'll learn one less. One of these is redundant and can be derived from the other 3, and I'm naturally lazy, so why would I need an extra? But I don't do that in physics 11. If you take first year university physics, you'll revisit these same equations, except you'll see them in calculus form, but it's going to be the same equations. These are it. These are the equations that describe how things move. Kinematics is the fancy word. A little notation. I use I for initial and F for final. In Britain, instead of using I for initial, they'll often use a little 0 for initial, and they'll call that V0, because they're saying at time 0, that's what you were going. And I'm fine with that as well. I'm just showing you these slightly different versions of those 4 equations. So if you see them, if you're watching a YouTube video at home, or you're watching something on the internet, or you're downloading an extra handout from the internet, if you ever come across that, we're using identical notation just about. We're using V0 and VI interchangeably. Okay? And in Britain, a 0 is not a 0, it's a naught, right? N-A-U-G-H-T. You may occasionally hear me say that because my high school physics teacher, who was one of my nerd heroes, was British, and so I always learned V0 and T0, so I may say that once in a while. Let's use this. I use an approach that I have nicknamed DFIC. It's an acronym. The D stands for list your data. And what I mean by that is I've actually done the D step for you here. But if it's a word problem, you're going through, what are they asking me to find? Put a question mark next to that, and then go through it looking for physics numbers and physics words. The F stands for find a formula. The I stands for insert the numbers. And the C stands for calculate the answers. This is not the end-all, be-all method, but well, Tyler, if you give me a tough question and I don't know what to do, I'll almost fall back. I'll start to DFIC. Eventually, as you get good at this, you'll start to skip some steps, and I won't freak out as long as you're getting 100% on stuff. I'm good with that. But this will be our fallback whenever you give me something new and nasty. Well, what are they asking me to find? I'll put a question mark next to what they're asking me to find. What else have they told me? I'll go through the question looking for numbers and physics words. Okay? So let's do one together. Example 1. So for this lesson, I've done the D part. I've listed the data for you. So this would be, I've pulled this from a word problem. Noor, what are they asking me to find? What has a question mark next to it? Okay. If this was a word problem, it would say something like this. A car starts out going at 3.2 meters per second. It accelerates at 2.9 meters per second squared to a final speed of 29.6 meters per second. How long does that take? That would be the word problem. What are they asking me to find? And I noticed they gave me a VF, a VI, and an A. There is only one of those 4 equations that has a VF, a VI, an A, and a T, and nothing else in it. Which equation? So go look at your green sheet, which is in front of you. You're looking at that row of 4. Only one of those equations has a VF, a VI, an A, and a T in it. Which one? And that's the skill we're going to pick up, we're going to practice today. No. I don't know, convince me. Read it out loud. No. We're not on that line. So you haven't been that's the line we're on. Those 4 are the ones we're on there. The one that starts out VF equals VI. Okay? That's the big row. So we're staring at that. Look at those 4. Only one of those has a VF, a VI, an A, and a T in it. Which one? Good. Write that down.
I'm going to be a little casual in my vector notation as I'm doing my work. I'll bring in vectors at the end if I need to. What am I trying to find, Noor? Put a little dot above the T. What side is the T on, the left side or the right side? So the left side, the VF is just going to drop down like a domino. Do that, please. What's right next to the T? What's the A doing to the T? How will I move it over? Remember that, remember that, remember that. What else is on the same side as the T? What's the VI doing to the T? How will I move it over? Remember that. I'm going to divide by an A. I'm going to subtract a VI. Which one do I do first? It's always reverse BEDMAS. So I'm going to, yes. And then divide that whole thing by A, and then look up, don't write this down. Noor, technically that equals T, but we're used to seeing the thing by itself on the left, so I'm just going to go T equals and just do that in my head. Write that down. That's our new equation. In fact, this equation contains 4 different equations. We're not going to memorize them. We're going to learn how to derive them. I've given you the main 4 on your formula sheet. We will learn how to rewrite them. If you can buy into this, I've dropped your memorization down by about 90%. Now we're going to plug in the numbers. What was VF exactly as a number, Noor? Good. Minus, what was VI exactly as a number? Divided by, what was the acceleration exactly as a number? So now get your calculators out, all of you. Here, if you have the fancy schmancy fraction button, you can use that. Otherwise, Noor, is this a fraction? Is there more than one thing on the top? I've got to open up a bracket. 29.6 minus 3.2. Close off the top, divided by. Is there more than one thing on the bottom? Do I need a bracket around the bottom? You could, but it's unnecessary. What'd you get? What'd you get? To 3 sig figs, please. 9.10. I totally agree. Units. Good. And then I usually put a box around it when I'm done. Let me pause the video for 1 second. At the beginning of the lesson, I said deriving stuff wouldn't be on the test. Starting here with example 1, this is all fair game as far as I'm concerned. In fact, on your test, this will be an actual test. I'll probably give you 4 or 5 like this on the written section where you'll have to identify the equation, rewrite it, and solve. Let's do another one. Next page. Example 2. Example 2. Jesse, what are they asking me to find? Which equation? I'm looking for the only equation that has a VI, an A, a T, and a D in it. There's only one. Do you say VF? I don't see a VF here. Try again. And that's how you're going to do this. You cannot pick an equation that has something you don't know. Yep. It's okay. This is how we get good at this. You okay? T plus a half AT squared. We'll read that one as D equals VIT plus a half AT squared. You don't have to say 1 over 2. D equals VIT plus a half AT squared. Yes, absolutely. That's the one. What you're going to hear me say very often, by the way, there's 5 concepts, 5 things. There's VI, VF, time, T, A, acceleration, and D, displacement or distance. If you know any 3, you can find the 4th. And once you have 4, you can find all 5. So really, if you know 3, you know 5. Which equation? Read it out again, Jesse? Good. What do I need to get by itself? Oh, bonus. It already is. That'll happen sometimes. So we can go straight to plug and chug. What was VI as a number exactly? No, it wasn't. What was VI as a number exactly? Yep, Jesse. Negative 1.5? What's t? Yep. Plus, how would I type a half on my calculator? What's the easy way to do that? 0.5. A is 4.5. 12. Don't forget the squared. If this was a word problem, Jesse would say this. A car starts out going backwards at 1.5 meters per second. It accelerates forwards at 4.5 meters per second squared for 12 seconds. What's its displacement? How far is it from its starting point? Okay. How will we type this in? Look up. I think I told you earlier this year, although I use brackets to show multiplying when I handwrite, I don't use them on my calculator. So you can type this in one line. I would go like this. Negative 1.5 times 12. I would not hit equals. I would go plus 0.5 times 4.5 times 12, and I would hit a squared. And if you've listened to me and you got a good calculator, it'll do the bed mass and order of operations all for you. Now you need to find your x squared button. You all have one. The reason you have one, by the way, is primarily because of this equation. It shows up so often in physics. If you do this right, 306. If you didn't get the 306, now is your chance to ask and I'll help you. 306? Yep. Units, Jesse, it's a distance. Okay, now, here's what Jesse said. Meters? So, ready? Little trick. If you blank on units, go look at another question. I probably used the correct units next to that concept because I'm not going to put the wrong units. In other words, I could have jumped down to here and I could have said, oh, there's a meters next to this D. Please clue in. You can use that trick. Yes? Meters. Brian. Okay, don't clear your calculator. Don't clear your calculator. Pause for a second. Now we're going to take a serious jump. Tony, example 3, what are they asking me to find? What are they asking me to find? VI. If this was a word problem, it would say something like, a car accelerates backwards at 3.5 meters per second for 24 seconds, and it ends up 40 meters behind from where it started. See all those negatives? How fast was it going to begin with? That would be the word problem. Which equation, Tony, has a VI, an A, a T, and a D in it? There's only one. Hang on one second, please. It's the same one that Jesse just gave us. Yep, it's that. Let's write it down. The way I mark these, by the way, I would give you a half mark just for coming up with that. Ooh, what am I trying to get by itself? Put a dot above it. What side is the VI on? Left side or right side? So what's going to drop down like a domino? Ka-thunk. What's right next to the VI? How will I move the T over? Remember that, remember that, remember. I'm going to divide. What else is on the same side? A 0.5 AT squared, or a half AT squared, and that's one term. What's the 0.5 AT squared doing to the VI? Adding, subtract? How will I move it over? What's the correct order? Reverse bedmass. So tell me what to write. 0.5 AT squared. And then what? No? All divided by T. That equals VI, but do you mind? I'm going to put VI equals on this side. That's another equation, Tyler. Are you going to memorize it? No, I will teach you to derive these. And you're not going to try adding all these to your green sheet, because it's going to look like your pencil threw up on the page. Now that we've, oh, by the way, I would give you a half mark if you got to there. In other words, if you can get to here, I usually make these worth 2 marks. You've got 1 out of 2. Now we're going to plug in the numbers. D was negative 40 minus 0.5. A was negative 3.5. 24, don't forget the squared, divided by 24. All of you want to try typing this in, because this is about a C+ level question. We're going to get tougher typing than this by a long shot. So once you've written it down, then you can go to your calculator. Ready, Brian? Okay, pick your calculator up. Is this a fraction? Yep. Is there more than one thing on the top? So we're going to open up a... Yep, good. And then negative 40. Make sure you use your negative button, not your subtraction. Take away. And then I'm going to go 0.5 times negative 3.5 times 24 x squared button. Close off the top. Divided by... Brian, is there more than one thing on the bottom? Do I need brackets around the bottom? I have no idea what the answer is here. I'm doing some quick math in my head. I think you could get a positive answer. I think this car started out going forwards. 40.333333333. Okay. Units, Tony. My S's get messy. Example 4. Josh, what are they asking me to find?
Yeah.
And it looks like they gave me VI and A and D. Which equation? Same one as before? This equation here has a T in it. I do not see a T here anywhere, so I say to you, no, no. There is only one equation that has a VF, a VI, and A, and a D in it.
VF
Yes. VF squared equals VI squared plus 2AD. Josh, what one we're trying to get by itself?
VF.
Oh, the VF is the VF by itself? No, the VF squared is by itself. Hey, Josh, what's the opposite of adding? What's the opposite of dividing? What's the opposite of squaring? Square root. We're going to have to square root both sides. So this is Mr. Dewick being lazy but organized. You ready? Here's what I'm going to do to show my work, but not rewrite a bunch of stuff. And I'm fine if you do this. I'm going to cross out the squared, and I'm going to draw a big square root sign on the other side. As far as I'm concerned, that's enough work, Josh. You've shown me your thinking, and I'm good with that. Now we're going to plug in some numbers. So VF is going to be big square root. It's going to be 12.5 squared plus 2 times 9.8 times 126. How many of you have the fancy schmancy fraction button that does the two-level fractions? You folks, when you press your square root button, I think it does an indent and it automatically extends the square root line. So you can probably just type this in. The rest of us that don't have that, Brian and others, here's how I tend to do complicated square roots. I don't. What I do first is I type what's inside the square root. I'm going to go 12.5 squared plus 2 times 9.8 times 126. I'm going to do what's inside the square root, hit equals, and then I go square root answer button really quickly. See if you can get 51.24304, 51.2. See if you can get that. So try getting that. Try typing. And again, this is why I keep saying you want your own calculator to figure out how your calculator works. You'll have to figure out how yours does this a little bit, but such is life. Okay? 51.2. Josh, you got that as well? Units. Good. Couple more, we're done.
Now, I have not, because I said to you there was 16 equations, 4 equations, and each of them has 4 variables. Aaron, if you're clever, you may have noticed I only went to example 6. I have not done all 16 variations. Some of them I'm going to let you try and figure out on your homework on your own. But what I will do on Teams, I will push out a showing all my steps answer key where I show you how I rewrote every single equation if you get stuck. Is that okay, Aaron? Good. Aaron, which equation? Yep. By the way, what you're going to find by about the middle of next week, your brain will have developed a subconscious circuit. You'll glance at this and the equation will pop into your head. It just will. Okay? Quick like a bunny. So, Aaron, I agree with you. We're going to write down VF squared equals VI squared plus 2AD. What am I trying to get by itself? Okay. You don't have to put a dot, but I find just even identifying what I'm looking at helps me see how it's all put together, because what side is the A on? What's going to drop down like a domino? The left. And I always do that first if I can, because it gives me a nice reference where other stuff is going to go. What's right next to the A, Aaron? I'll give you a hint. 2 things. What are the 2 and the D doing to the A? So how will I move both of them over? Remember that, remember that, remember that. What else is on the same side as the A? What's the VI squared doing to the A? How will I move it over? Which one am I going to do first? Reverse BEDMAS. Talk to me. What am I going to write? Minus VI squared, and then all divided by what? Yes. Not 2A. I want the A to stay where it was, right? Common mistake. Oh, and then if you don't mind, Aaron, I'm going to put the A equals on this side. Okay. VF squared is 12. Don't forget the squared. VI squared is 20. Don't forget the squared. All divided by 2 times 86. Aaron, do you have the fancy schmancy fraction button? So, is this a fraction?
Yeah.
Is there more than one thing on the top? I'll have to put brackets around the top. Ooh, is there more than one thing on the bottom?
Yeah.
I'm going to have to put a bracket around the bottom, too. Okay. Ah! Did you all get a negative? Should that make me nervous? Wait. Aaron's still typing. We'll let him type. And by the way, you also get faster at typing, which is why I'm telling always type in class, because that way as you do the homework, you get faster and faster. Did you get negative 1.48? What was VI as a number exactly? What was VF as a number exactly? Did we speed up or slow down? Should I get a positive acceleration or a negative acceleration? You know what? The negative doesn't make me nervous. It actually confirms I probably did this right. To 3 sig figs, I think negative 1.49. Yes? Units for acceleration, Aaron, my friend.
Meters per second squared.
Mm-hmm. Well done. The last one. Okay. Mara, what do they want me to find? Which equation? D equals VIT plus a half AT squared. Problem. What do they want me to get by itself? How many t's are there in this equation?
This is a problem because if I get this t by itself, I would have moved that one to the other side. If I get this t squared by itself, I'd have a t on the other side. Who's in Math 12? It's a quadratic. They don't yet know x equals negative b plus or minus the square root of b squared minus 4acl over 2a. But in Physics 12, we can solve this using the quadratic formula. In Physics 11, oh, I like example 6, I like example 6, I like example 6. Example 6 is a nice question. Why would I say that? Did you hear me say it's going to be on the test? You're the kind of student that notices when a teacher sends emphasize? Good, good, good. We can solve this because I had to contrive something. Mara, look at your data. One of your values is a 0. Which one? What's in your head 0 times 5? What's 0 times 10? What's 0 times a bajillion? What's 0 times anything? If v is 0, what's 0 times t? Because v is 0, that whole term cancels out. And I get yet another equation, a special sub-equation. D equals AT squared over 2. Mr. Derrick, I thought it was a half AT squared. That's what I wrote. See the half? I just didn't write the 1 because does multiplying by 1 change anything? I'm lazy, and I think that looks prettier. Go with example 6, and I'll scroll back for example 5. Now how many t's are there? We can get this by itself. How? I'm going to be lazy, but organized. What's the a doing to the t? How will I move it over? I don't want to rewrite everything. I'm going to go like this. Cross out the a, tuck it down there. What's the 2 doing to the t? How will I move it over? I don't want to rewrite it. Cross out the t, tuck it right there, and we have the t by it. No, we don't. We have the t squared by itself. How does one get rid of a squared, one wonders? So I'm going to cross this out, big square root, and here is an equation that we're going to run into very often. This is when you're analyzing free fall and you're dropping an object from a cliff. T equals the square root of 2d over a. Let's plug in our numbers. 2 times 2,400 all over 20. What do you get? Oh, again, I'm going to type what's inside the square root. 2 times 2,400 divided by 20. And then I'll go square root, answer button. And I get 15.5. And it's time, so it's seconds. Okay. Is that okay, Oliver? Pardon me? I figured that. I'll come help you because we're basically done. Your homework is try every question. I haven't covered every permutation and every way to rewrite the equations. I'll send out an answer key showing all my steps. You're going to have a lot of homework tomorrow. Thursday is going to be pressing pause because you have a 4-day weekend. I don't want you to have a whole bunch of homework. I'll give you a take-home quiz on Thursday, but there won't be a new lesson on Thursday. That's a chance for everything to kind of come and get put together. Okay? Let me pause the video recording.